All right, so we start the lesson data representation methods in computer systems, and as we discussed, we get to know what is like why we need data representation, and we get to know like there are four kinds of actually the three kinds of number system, because we know about the decimal number system so far already, like we have practiced it for like almost 10 years, right? And we are going to know the new number systems, right, which is binary, octal, decimal, and hexadecimal, right? And as I remember, we copy this table into your book. Did we, people? Can you confirm?
Yes, sir.
Yeah, we did. Great. So today, I'm going to show you, first of all, like how to recognize any particular value belongs to which kind of number system. Like if we are given a particular value, we can decide which number system like belongs, like that, to which number system that number is going to belong, right? So as an example, I can take a particular number, like let's say I'm going to talk about the number 101, right? And actually, like we can't say it is like 101.
Where's the scissors?
This is scissors, right? So because 101 is a term or a name we are using for this particular value, then we are referring it to the decimal number system, right? So Haram, please get in the listed menu, then you go to that table and go look at it. Come here. Do it over there. Do it over there. Right? Go there, Suzu, please. Suhana, here and do it. Careful with your hands. Right, so we can't actually name this as 101. So what I can give is like the value 101. Right, value 101 is given, and we are there to decide to which number systems that this value is going to belong. Right, so like to determine to which number system that a particular value is going to belong, is like what we have to do is we have to recognize what are the different characteristics that the value is having, right? So as you can see, this has different kinds of, like two different type of characters in this value, which is 0 and a 1. So like two different characters, right? 1 and 0. In here, the 1 has been repeated. So now what we are going to do is we are going to search these two characters inside these number systems. So if any number system contains these two characters, we can say the value 101 can be belongs to that particular number system, right? So you will realize, since we are searching for 1 and 0, this 1 and 0 is there in the binary number system, as well as the decimal number system, as well as the octal number system, as well as the hexadecimal number system. So without a doubt, we can say the value 101 is belong to all of these number system. That means 101 is a legal value in any particular number system. But we only refers 101, the name 101, only regarding the decimal number system. Decimal එකට අදාළව විතරයි අපි එකට 101 කියලා කියන්නේ 101 කියලා කියන්නේ. We can't tell like 101 in octal. right? It's because it is not talking about hundreds. It's talking about the group of 8s octal value. So we can just say 101. The value 101 is also belongs to the octal, and 101 is also belongs to the binary. So then we are getting a question like how we can recognize, like when it comes to the 101, how we can recognize whether it is a decimal value or an octal value or a binary value, how we can recognize that thing. To recognize the base or the particular number system that this value is going to belong, we have to mention the base with it. So this is called the base, right? So once the base is mentioned, we can say this particular value now is a binary number, right? If I write 101 with the octal base, or like as an octal value, so it's going to be 101 in base 8. People, are you clear with this?
Yes.
Great. How about others?
Yes.
Yes.
Right, great, great. All right, so I'm not going to give you any notes regarding this. It is just a general knowledge that you are going to have, right? So I'm going to take you to the rest of the lesson, right? So before that, let me ask this question, right? So tell me the number systems that these values are going to belong. If I say 102, to which number systems that this value can be belongs to? Yes. Let me have the answers on the chat. Yes, yes. That is correct. KPS Ratnayaka, and yeah. So I can, what's the name, Puta or Dua? That's right. Bilendia, that is right. Dulandi, that is right. Yes. So when it comes to 102, so it has 3 different characters, right? The 1, the 0, and the 2. So those things can be found, all those things can be found inside these number systems. The binary number system is just having 0 and 1, 2 is not there, right? So because of that, we cannot say that it belongs to the binary, but 102 belongs to octal, decimal, and hexadecimal, right? Very good. So what about this value? 476. How about that? Yes, 476. Yes, yes, the same number systems again, right? Very good, very good. Okay, then what about 239? What about that? 239. Dilendia, Rison, think about it again. You have made a mistake. Malitu, yes, that is correct. Sanushi, that is correct. Hey Sarah, yes, that is correct. Dulandi, Dilendia, yes. Now, yes. It belongs to decimal and hexadecimal. It cannot be a number at octal because 9 is there. So 9 is not a character of the octal number system, right? So you have to find all 3 characters, 2, 3, 9. So 2, 3, and 9 stays only in the decimal and hexadecimal. Yes, Rizwan. Now, when it comes to, let's say, 2CF, and definitely, if you find letters in your value, it goes with what? Hexadecimal. That's correct, right? It goes with hexadecimal because it is only the hexadecimal number system, according to our syllabus. It is only the hexadecimal number system that we have letters inside it. Okay. So I think you are very clear with that option, with that the technique of determining the particular number system. So now let's move to the next part. All right. Now, when it comes to the number systems,
let's do what shining armor is.
In the computing, there are certain situations, like there are certain ways that these number systems are used for the computer. And I think I have mentioned this earlier as well, but I'll recap it. So this is one particular place we use numbers in a computer. So these numbers, the ones that is being circled with a circle with a red circle, it determines, it shows you what kind of numbers are being used to represent a color, right? We call this the RGB representation. It's simply about how much of red, how much of green, and how much of blue are being used to create this purple color, right? So as it shows, it says there are 135 of reds, 31 of green, and 120 of blue has been used to create this purple color. Which purple color? The purple color that they have taken into this area. So if I click my mouse pointer at somewhere else, it will change these values automatically. Right, and as well as there is a value over here as well. It is not that much clear, and it is something like this. Hash 871F78. Right, we call this the hex code. Right, so hex code is used to represent a color again. So something that can be represented as RGB colors can also be represented as a hex code, right? In the picture that is in your book, it represents both the ways, right? You can manage the RGB values, so it will manage the color, as well as it will change the hex code regarding that particular color. Or else you can change the values of the hex code. So according to that, RGB colors will be changed, and this particular color shows in this book will be changed. Right? So it is one particular place that they use numbers to represent a particular color in a computer. Now, when it comes to this hex code, these values are represented as a hexadecimal value, right? So hexadecimal number system is involved. And when it comes to the RGB values, the values over here, right? These RGB values, they are represented as decimal values. So decimal number system is being used. But when it comes to the computer, all these decimal values as well as these hexadecimal values are converted into machine code. That means ones and zeros, right? So likewise, a very big bit stream or a bit pattern or a sequence of bits will be used to represent a particular data. And that is done to understand by the processor, right? And why we use these decimal values as well as hex values, that is for the understanding of the users, right? Okay, people, is that clear? How these number systems are helped us when we are doing the computing?
Yes, sir.
Right, great. So in this lesson, we have to know about these kind of situations, and more importantly, what we have to do is we have to go through a particular number system conversions to understand how these number systems are related to each other, right? So that is the major aspect in this lesson. And regarding the exam point of view, it is the place that you are going to have the questions regarding this lesson. So there will be, like we know already that there are 4 different number systems that we have to learn, and you have to know how the conversions can be done in between these number systems. So conversion in the sense, like if you are given a decimal value, you should know how to convert into a binary. If you are given an octal value, you should know how to convert it to a decimal. In other case, you will be given a binary value, then asked to convert into an octal, right? So there are certain techniques for this. So today we are going to learn about those kind of techniques, right? So before we go to the conversions, there are some specific placements that we have to understand, right? And specific terms are also there, right? So as this explains, each number system is made of something called unit, something called numbers, and something called base. And unit, it is called a single object. For instance, a mango, rupee, and a day can be considered as a unit. So when it comes to the number system, units are going to be the different characters, right? If you take a binary number system, there are 2 units, 0 and a 1. If you take, when it comes to the decimal number system, there are 10 units, 0 to the 9, the different 10 different symbols, right? So likewise, there will be units. And there will be number, right? So number is a symbol which represents a unit or a quantity, right? So we can use those units. We can use the numbers to represent those units, right? So to represent 1 unit, we use 1. To represent 2 units, we use 2, likewise. And the base and the radix, right? So that is talking about the identification of the number system. So identification in the sense, like as we discussed earlier, like if I just write 1, 2, 3, I can't say what kind of a value is this. So to make sense, I have to give a particular base. So now I can say, okay, this 1, 2, 3, this value is in octal number system, right? So if I say 3F, then I have to say it is hexadecimal value, right? So the base indicates, or base gives the idea what kind of a number system, what kind of a value that we are referring to. Right. So is that clear, everyone?
Yes, sir.
Okay, great. So shall we write this down onto our notebooks before we go for the conversions, right? So yeah, I will highlight you the things so you can go with the Yeah, we'll write this regarding all the number systems. Hold on. Yeah. Yeah, let's go with that. Yeah, you can go it like this. Like after the table that you have drawn, right? You may write these things down, right? So write it as points. Each number system is made of unit number and base of the radix. So then you write about the definitions that they have given. And you don't need to write any specific topic regarding that. Just write it under the table. I think the table is the one that you have written as the last as the last content. So continue with these things. All right, one is done. How about others?
Sir, I'm in the last one, base and ready.
Okay, Rizwan. Okay. Okay, are we done? Anyone who is still writing?
Is anyone still done?
Okay, so moving forward. Yeah, so yeah, now here they have like explaining you like the things, the base and all these things in a very deep manner. Really, you don't need that kind of things because you know what the things are. So like I'm taking your attention to something like this, which is called the most significant bit and the least significant bit. So this most significant bit and the least significant bit terms are derived out of this most significant positional value and the least significant positional value. Now, when it comes to the most significant positional values and the least significant positional values, it describes which has the highest value and which has the lowest value regarding a particular number, right? Or regarding a particular value, right? So yeah, let me illustrate it to you using the whiteboard. So yeah, can you all see this whiteboard clearly?
Yes, sir.
Yes, sir.
Okay, now when it comes to the most significant positional value and the least significant positional values, we always try to figure out which particular character has the most value and the least value, right? So if I take the terms, the most significant digit, MSD, and least significant digit, LSD, right? For any number system, there are these two terms, MSD and LSD. It's a universal word, most significant digit, which is abbreviated from MSD, least significant digit, which is abbreviated from LSD, right? Any particular number in any number system has these two characteristics or like these two positional values. So how we are going to recognize this, right? So let me take some numbers and show you what is the way that you can manage this particular most significant digit and the least significant digit. So let's take a simple value like 123. And here, the most significant digit is going to be the 1, and the least significant digit is going to be 3. So what is the base of saying that fact? When it comes to the whole numbers, which does not have floating point values or the decimal points, if it is a whole number, the most significant digit will be the leftmost value, which is not a 0. The leftmost value, which is not a 0, is considered as the most significant digit. So in that case, in 123, 1 is going to be the most significant digit. And regarding the least significant digit, or the LSD, it explains for a whole number the rightmost value, right? So any particular number or a character that you can find at the very right end will represent LSD, and that is regarding the whole numbers, Purna Sankhya Varata Vitara. right? So as an example, if I write something like this, like 0, 7, 2. Now here, the most significant digit is going to be the 7, because 072 is a whole number, and most significant digit is defined the leftmost value, which is not a 0, right? And what's going to be the least significant digit? It's going to be 2, right? And in case if the number represents in a single digit, like 8, then both the most significant digit as well as the least significant digit are going to be the same value, right? Because there's only one particular value. Is that clear, everyone?
Yes, sir. Yes.
Right, great. Okay, so what happens when it comes to the decimal values, right? So when it comes to the decimal values, let's take an example, something like this. 23.75. So in that case, since this left-hand side represents a whole number, still, the most significant digit applies the same rule for the whole number. The leftmost value, which is not a 0. So 2 is going to be the most significant digit. And when it comes to the decimal part, it's going to be the rightmost value after the decimal point, the rightmost value, which is not a 0. So in this case, 5 is going to be the least significant digit, right? So if I show you another example, like let's say 8.50. So 8 is going to be the most significant digit. And here, this 5 is going to be the least significant
Dad, look at
digit.
this.
That's very nice, Susu. My God, that's very creative. Oh, that's nice. Wow, that's very nice, Susu. Oh, my bad, my bad.
Dad, it's okay.
You keep it to until Mom comes, right? So you can show it to her. That's very nice. Right, so yeah. So the 8 is going to be the most significant digit because it is the rightmost value, which is not a 0. And 5 is going to be the least significant digit because it is the rightmost value, which is not a 0 again, right? And that applies for the decimal numbers, like floating point numbers, which has a decimal point. Is that clear, everyone? Okay, right. Now, what happens if we get something like this? Let's consider about 0.062, and I put a 0 over here as well. Now, we have to be very careful. Now, in here, they don't have anything in the whole number part. It's a 0.
The most significant number is 6 and least is 2.
Yes, it's going to be like that, Rizwan. So most significant is going to be 6 over here because it is the one which is in the leftmost, which is not a 0. And the least is going to be to the rightmost value, which is not a 0. Okay, so I think you have a clear idea about what is the most significant digit and what is the least significant digit. Are we, people? All right. Okay, so let's first write about this and then we'll come to write this particular example. Right, so, okay. Yeah, people, have to excuse for this, right? Give me a second. Yeah, sorry for that, people. I had to answer that call. Okay, let's go with Durandi. We were just talking about the most significant and least significant things, and now we are going to write the descriptions regarding that though, so you didn't miss a much. So let's go with the topic: most and least significant positional value of a number. So have that heading, have that topic.
The side will be green.
And as the first point, you can write this under that. Okay, one is done. How about others? Anyone who is still writing?
Anyone who's almost finished?
The last 2 lines. It's supposed to.
Okay, go on, go on. Okay, Sanetma and Sandini, once you're done, let me know.
Answer. Answer. Okay, moving forward. Yes, yeah. Regarding the decimal numbers, we can write this portion. Maybe. Yes, we'll write this particular thing as the second point. Then we can go for the one we have drawn. Lamai, let you know one's done. Okay, one is done already. Okay, Udan, you are so fast. Yes, that's good. Others, let me know when you are done. Okay, two are done.
Yes, and me.
Okay, anyone who is still writing?
Should just mix it up.
That's
Okay. So shall we move to the whiteboard? So we can have the example regarding this. All right, so I'm showing you the whiteboard. So this is the example that you are going to write under your note. And when you are writing the terms MSD and LSD, it's better you like name it later. Later means like you can make a square and say MSD stands for most significant digit. LSD stands for least significant digit. Oh my God. Likewise. So Mihini, yes, you have to write this word. Okay, one is done. How about others?
Done, sir. Done, sir.
Right, okay. Anyone who is still writing?
Yeah. Now picture. Yeah. Yeah. Now you can take
Right. So we are moving to the next part, which is called the most significant bit and the least significant bit. So now, when you know about the MSD and LSD, most significant digit and the least significant digit, if the number system is going to be the binary, we can refer the most significant digit and the least significant digit as most significant bit and the least significant bit. Because the term bit, BIT, is used to refer or like it is used to identify a 1 or a 0, right? So because of that, we can use a special term which means a more significant bit and the least significant bit. So that is the part that they are talking from this particular place, right? So if I take it to our whiteboard, so the more significant bit and the least significant bit comprises of the binary numbers, right? So I'll take it like this. MSB, more significant bit, and LSB, least significant bit, right? So I'll take a simple example. 1010.110, right? Let me have another 0 at the top. So we can simply illustrate this is as the MSB and this is as the LSB, right? So if I just talking about a whole number, if so, this one is going to become the MSB and this 0 is going to become the LSB. Right, so the only thing that you need to understand is the terms MSB and LSB is there only for the binary number system because it is dealing with ones and zeros. Are we clear with that, people? Yes, everyone? Are we clear with that?
Yes.
Right. Okay. So let's go with the noting things down. And it's better you write this heading, more significant bit and least significant bit. Yeah, Sanushi. Yeah, I'll come to that. Hold on. Yeah. So after the heading, let's write it like this, Sanushi. Then after I'm going to explain to you again. So let's write it like this. When it comes to the binary number system, most significant positional value is named as most significant bit, within brackets MSB, most significant bit, within bracket MSB, and the least significant positional value is named as least significant bit within brackets LSB. Okay. Right. Then after, you can write this as the examples. And Sanushi, it's nothing to for you to understand if you are familiar with the more significant digit. When it comes to the binary values, it is referred as more significant bit. Right? The more significant bit is going to be the leftmost value, which is not a 0. Least significant bit, the rightmost value. Whole number, the rightmost value. If it is a decimal number, it's going to be the rightmost value, which is not a 0. Sanushi, is that clear?
So you have pointed 0 in the second one and not in the first one as the least significant bit.
Come again, Dua. Come again.
So in the second,
Sanushi, come again.
sir, in the second whole number, the least significant bit is it 0?
Yes, yes, Dua. So like it is a whole number. No? This is a whole number. It doesn't have any decimal points. So when it does not have a decimal point, the least significant one is going to be the leftmost value. Right? Like we did it in the least significant digit as well.
So then we can consider 0.
Yeah. මම මෙතන ඒකට එකක් ක්ලියර් නෑ නේද? එතනට එකක් ක්ලියර් වුණා නම් හොඳයි. Right people, it's better you have something like this as well. මට ඒක මෙතනදී example එකක් විදිහට ලියන්න බැරිලා. So write the value like 720. Right? In there, the most significant is 7. And the least significant is going to be a 0. When the decimal values are not there, 0, the leftmost value is going to be the least significant bit. Right? Again, සාමාන්‍ය ගණිතය වගේදී තමයි දුවන්නේ. In the normal mathematics, we disregard the leftmost 0. If it is a decimal value, floating point එකක නම් we disregard the rightmost zeros. So same happens here. Is that clear, everyone? I'm sorry, I really couldn't write an example like that. Right, Sanushi. Right, it's better you add this 720, which illustrates the MSB and the LSB as well. And then after, you may go with this Okay, are we done?
Yes, sir.
Right. How about others? Anyone who is still writing? Okay. So moving forward. So after the LSB and MSB, then we have the conversion among the number systems. Right. So to do this, I'm going to take the whiteboard again, and then let's discuss about this. So when it comes to the conversions, in this lesson, there are like 4 types of conversion that we need to go through, right? Maybe in your school, they may teach you many number of conversions, but actually there are only 4 types of conversions in the computing, right? So we only need to learn about what are those conversions are, right? So when it comes to the conversions, the first conversion type that we are going to learn is we are learning how a decimal value is converted into a non-decimal value. So in our case, we are going to learn how to convert this into the binary, into the octal, and into the hexadecimal, right? So that is going to be the first conversion type. Right. So after that, we are going to learn the reverse of this thing, like how the binary, the octal, the hexadecimals are being converted into a decimal value. Right? So that's going to be the second type of conversion.
Yeah, and also it's not there. I think he's gone.
Yes, yes, yes. So I think so. And the third type is like converting.
Like my Anna, the small Elsa, like my Anna, it looks like she disappeared.
Yes, yes, yes.
Did she disappear into thin air?
Maybe.
Yes, maybe she.
Like the third one is going to be, we are going to convert the binary values into the octals and into the hexadecimals. That is the third conversion type. And as the last conversion type, we are going to convert the octal and the hexadecimals into the binary. So that's the last conversion category, which is the fourth. Right? So these 4 things contains 4 different ways of doing this. So if you learn 4 techniques, that's all for you to learn. Okay. So let's write the topic. Let's write it in a common way, right? So have the topic like this. You're going to say it. Let's say number conversions. Yeah. Or simply say conversions. Right? So the topic is going to be conversions. Conversions is going to be the topic, and under that you may write it like this. Write it like this. There will be there will be 4 types of conversions. 4 type of conversions. In between number systems. In between number systems. As follows. As follows.
In conversions.
Yeah. I can't remember what I have said properly. Like, yeah, can anyone repeat?
There will be 4 types of conversions in between number systems as follows.
Yes, there will be 4 types of conversions in between number systems as follows. Got it, Rizwan?
Yes.
Right. And full stop and continue. The categories have shown, using the base of the number systems. The categories have shown using the base of the number systems. The categories have shown using the base of the number systems. Okay, so let's draw these 4 categories. Then after we can go for the first one. Those are why? All right, are we done? Anyone who is still writing?
This in the board.
Yeah, it's on.
Yes, I have stated.
Okay. Keep going.
Done, sir.
Okay, Rizwan. All right. So, yeah, people, now since I have to go for the very first conversion, and since it will take little time, I'm going to end the session from here today because we have another 2 minutes to go with the session. So I'm not going to start the new topic, otherwise there is no point of stopping at the middle of our explanation. So I'm going to end the session from here for today. So by next week, we are going to learn these 4 conversions with the examples, and we have to do some, you have to do some conversions during the class time. So get ready, right? And we will be experiencing the things, right? So thank you very much, everyone. So I'm going to end the session from here just for today, right? So I will see you on next week for the very same time, right? So thank you very much, everyone. Keep going, right? I'll see you on next week for the very same time.
Thank you, sir.
Thank you, sir.
Right, okay. Thank you very
Thank you,
much.
sir.
Thank you, sir. Therwan sir.
Right, okay, sit down. Reason, I'm sorry, Reason. Thank you, Reason.
Yes.